In aqueous solution, ammonia reacts as represented above. In 0.018 molar NH3 at 25 degrees Celsius, the hydroxide ion concentration, OH-, is 5.6 times 10 to the negative fourth molar. In answering the following, assume that the temperature is constant at 25 degrees Celsius and that volumes are additive. Write the equilibrium constant expression for the reaction represented above. Determine the pH of 0.018 molar NH3. Determine the value of the base ionization constant Kb of NH3, and determine the percent ionization of NH3 in 0.018 molar NH3. The equilibrium constant expression for the reaction represented above, NH3 plus H2O yields NH4 plus OH-, is K equals the concentration of the products over the concentration of reactants, only including aqueous and gaseous solutions, which is the concentration of NH4 plus times the concentration of OH minus over the concentration of NH3. We are given that the concentration of hydroxide ions is 5.6 times 10 to the negative fourth. From the concentration of the hydroxide, we can calculate the pOH by taking the negative log of 5.6 times 10 to the negative fourth, which gives us 3.25. We can find the pH by subtracting the pOH from 14, which gives us 10.75. To calculate the value of Kb, we take our equilibrium constant expression and plug in the concentration for each of the values. To find the concentrations, I drew an icebox. NH3 plus H2O liquid yields NH4 plus ions plus OH minus ions. So H2O is a liquid, so we leave it out of the icebox. We are given the initial molarity of NH3 is 0.018 molar. The change is negative X because it's a reactant. So the equilibrium expression, or the concentration equilibrium, is 0.018 minus X. NH4 plus and OH minus are both products, so the initial concentration of both is 0. Then we add X because the concentrations change positively, so the equilibrium concentrations are X. Since we are given the concentration of OH minus is 5.6 times 10 to the negative fourth, we can say that X, which equals OH minus, which also equals NH4 plus, equals 5.6 times 10 to the negative fourth. So we plug in the equilibrium concentrations to find the value of Kb. So X squared divided by 0.018 minus X. So Kb equals 5.6 times 10 to the negative fourth squared divided by 0.018 minus 5.6 times 10 to the negative fourth. Kb equals 1.8 times 10 to the negative fifth. To calculate percent ionization, you take your X value and divide by the initial molarity. So 5.6 times 10 to the negative fourth is our X value, and 0.018 is our initial molarity of NH3. You multiply that by 100 and you get 3.1%. So the percent ionization of NH3 in 0.018 molar NH3 solution is 3.1%.